Welcome. Let this be the only place you need to be tonight. Let your breath slow, your shoulders soften, your mind loosen its grip on the day now behind you. There is nothing to solve here, nothing to remember. Tonight we drift through humanity's long, tender relationship with time itself, beginning with a simple phrase we've all whispered: time stood still. It describes those rare, hushed moments when change itself seems to pause, when the world seems to hold its breath beside us. Ancient Egyptians believed the sun god Ra paused his boat at the horizon each dusk. They imagined him sailing a golden vessel across the sky each day, and each evening resting briefly at the edge of the world before slipping into the underworld's quiet waters. This pause was seen as sacred, a breath between light and darkness. For them, twilight itself was Ra lingering, unwilling to fully release the day. In the book of Joshua, the sun and moon reportedly stood still over Gibeon. As the story tells it, daylight lingered far longer than it should have, granting extra hours for an ancient battle to unfold beneath an unmoving sky. For centuries, this passage has stirred quiet wonder among readers, who imagine the heavens themselves holding perfectly motionless above a small hillside town. Hindu cosmology divides eternity into repeating cycles called yugas. These vast ages rise and fall in gentle succession, stretching across spans of time so immense that human lifetimes barely register within them. Each cycle carries its own character, moving slowly from harmony toward change, before beginning again. It is a vision of time as breathing rather than racing, endlessly circling, endlessly renewing. Norse mythology tells of the world tree Yggdrasil holding time in its roots. Beneath its vast branches, 3 sacred wells were said to nourish fate itself, weaving past, present, and future together like slow-growing threads. The tree stood at the center of all realms, quietly anchoring existence. Some imagined its roots reaching so deep that even time moved gently around them, unhurried and patient. Greek myth says Zeus lengthened a single night to father Heracles. According to legend, he stretched those quiet hours far beyond their usual length, giving the darkness extra time to settle over the world. It is a gentle image, the heavens slowing themselves, the stars lingering a little longer, as though even the gods sometimes wished for more time within a single night. Chinese legend describes Houyi shooting down suns to slow endless daylight. The story tells of 10 suns scorching the earth together until the archer Houyi gently restored balance by bringing down all but one. What remained was a softer rhythm of day and night, a rest for the parched land below. Even now, the tale is remembered as a quiet act of restoring calm to an overheated world. The Maya calendar tracked time using an unbroken long count from a mythical start date. Every day since that ancient beginning was carefully counted, stretching across thousands of years without pause. It reflects a civilization deeply attuned to time's continuity, seeing each day as part of an unbroken thread, reaching endlessly backward and forward. The light we see in the night sky tonight has traveled longer than the entire span that calendar counts. Ancient Babylonians divided the day into 12 double hours using sundials. Each long segment marked a slow passage of shadow across carved stone, measuring time not in rushed minutes but in wide, unhurried arcs. Their sundials rested quietly under open skies, tracking the sun's gentle journey with patient precision. It was among humanity's earliest attempts to give shape to something as formless as passing time. Egyptians built obelisks whose shadows marked the passage of hours. Rising tall against the sky, these slender stone monuments cast long shadows that swept slowly across the ground below. As the sun moved, so did the shadow, offering a quiet, steady measure of the day's unfolding. Standing beside one, ancient observers could watch time itself drawn gently across the sand. Let your shoulders soften now, sinking a little deeper into whatever is holding you. There is nothing to figure out, nothing to remember. Let your breath grow long and unhurried, like a tide easing back from shore. With each slow exhale, let your thoughts loosen their grip, drifting further from the day behind you. You are simply here, resting, cradled by the quiet dark. Water clocks called clepsydras measured time through steady dripping in ancient Egypt. Inside carved stone vessels, water seeped slowly from one chamber into another, marking hours through its unhurried fall. Priests used them to track night rituals when the sun could offer no shadow to read. Drop by drop, time became something you could almost hear, a soft rhythm murmuring in the dark temple air. Stonehenge aligns with solstice sunrises, marking the year's turning points. Its great stones were placed with such care that, on midsummer morning, the sun rises precisely between them. For those who built it, this alignment marked the slow turning of seasons, a yearly promise that light would return. Standing among those weathered stones today, one can still feel that ancient patience settled into the earth. The Antikythera mechanism modeled celestial time cycles in ancient Greece. This small bronze device, found resting on an ancient shipwreck, held dozens of tiny gears turning in careful harmony. It could predict eclipses and track the moon's phases, a miniature universe held in metal and patience. Scientists still marvel at its intricate design, a quiet testament to how deeply the ancients longed to understand time's hidden clockwork. Roman calendars originally had only 10 months before January and February were added. That early calendar began in spring and simply left winter uncounted, an unnamed stretch of quiet, dark months. Over time, the Romans wove those missing weeks back into the yearly cycle, giving every season its rightful name and place. Even now, we still carry that ancient decision each time we speak of January. Julius Caesar introduced the Julian calendar with a leap day every 4 years. Guided by astronomers, he sought to align the calendar more closely with the sun's true yearly path. That extra day, tucked quietly into February, helped smooth the small drift that years of counting had gathered. It was a gentle correction, offered once every 4 years to keep human time in step with the sky above. The Julian calendar drifted about 11 minutes off the solar year every 12 months. It seemed such a small amount, barely noticeable in a single turning of the seasons. But across centuries, those quiet minutes gathered into days, slowly pulling the calendar away from the sun's true rhythm. It was a gentle drift, unseen at first, like a boat easing almost imperceptibly from its intended course. Pope Gregory XIII reformed the calendar in 1582, skipping 10 days. Astronomers had shown how far the old calendar had wandered from the sun, so 10 days were quietly folded away to restore balance. People simply woke one morning to find the date had leapt forward, a soft correction settling gently into place. It was history's calm way of resetting time's rhythm to match the heavens once more. England did not adopt the Gregorian calendar until 1752, losing 11 days. By then, the gap between old and new calendars had grown even wider than before. When the change finally came, the 3rd of September simply became the 14th, an 11-day step taken all at once. For a little while, people spoke gently of missing days, as though time itself had softly exhaled. Ancient China used water clocks and incense clocks to mark passing hours. Alongside dripping water vessels, slow-burning incense sticks traced time through gentle threads of fragrant smoke. Marked with notches, the incense would burn evenly, letting the hours be measured by scent as much as by sight. In quiet temples and homes, time drifted by on soft curls of smoke, unhurried and fragrant in the still evening air. Medieval monasteries used bells to mark canonical hours through the night. Monks rose in darkness at set intervals, guided only by the deep tone of a single bronze bell echoing through stone corridors. Between prayers, the world outside slept on, unaware of the quiet vigil being kept. In this way, faith and time were woven together, marked hour by hour beneath a canopy of candlelight and silence. Let your shoulders soften now, sinking a little deeper into wherever you rest. There is nothing to solve, nothing to remember, nothing to hold on to. Let your breath grow long and unhurried, each exhale releasing a little more weight from your body. Thoughts may drift by like slow clouds, and that is all right. You don't need to follow them anywhere. Just resting here is enough. Sundials cannot measure time on cloudy days or during nighttime. Without sunlight to cast its shadow, the dial's face falls silent, its lines and numbers meaningless in the gray light. For all its elegance, it depended entirely on the sky's cooperation, useless the moment clouds gathered overhead. It was a beautiful instrument, but a humble one too, bound completely to the sun's quiet favor. Mechanical clocks first appeared in European monasteries around the 14th century. Built from iron and patience, these early machines ticked with a steady clatter, replacing the need for a monk to watch the sun or stars. They were large, heavy, and imperfect, yet they offered something new, time measured by mechanism rather than by light. Slowly, their rhythmic sound became a fixture of daily life within stone walls. The escapement mechanism allowed clocks to tick at a regular pace. This small but ingenious device released stored energy in even, measured pulses, giving birth to the steady tick that we now associate with time itself. Before its invention, mechanical timekeeping had been erratic, drifting unpredictably from hour to hour. With the escapement's gentle click, time finally found a dependable heartbeat. Christian Huygens invented the pendulum clock in 1656. By harnessing the steady swing of a weighted arm, he created a timepiece far more accurate than anything before it. Each gentle sway back and forth became a quiet, reliable measure of passing seconds. His invention transformed clockmaking, letting time keep pace with the natural rhythm of gravity itself. John Harrison's marine chronometer solved the problem of longitude at sea. For centuries, sailors could measure how far north or south they had traveled, but not how far east or west, often leading ships astray. Harrison's precise, sturdy clock kept accurate time even amid rolling waves, letting navigators finally calculate their true position. His quiet persistence changed the course of ocean travel forever. Total solar eclipses momentarily darkened daytime skies. For a brief span, the moon slides perfectly between the earth and sun, casting a hush of twilight across the land in the middle of the day. Birds grow quiet, temperatures dip, and a strange, gentle darkness settles over fields and rooftops alike. It is one of the few times the sky itself seems to pause and hold its breath. The eclipse of 585 BC reportedly stopped a battle between Lydians and Medes. As daylight faded unexpectedly mid-fight, soldiers on both sides are said to have paused, startled into stillness by the darkening sky. Interpreting it as a sign from the heavens, the two armies laid down their weapons and sought peace instead. A moment of celestial shadow, quietly, became a turning point toward calm. Total solar eclipses can last only up to about 7.5 minutes. Despite the vast preparations and long journeys people make to witness them, the moment of full darkness passes swiftly, like a held breath, gently released. Within minutes, sunlight returns, warmth creeps back across the land, and the ordinary rhythm of day resumes. Its brevity is part of its wonder, a fleeting gift from the turning sky. Comets appearing in the sky were historically interpreted as omens disrupting time. Across many cultures, their sudden brightness against the fixed stars felt like an interruption in the natural order, a message meant to be read rather than simply observed. Kings consulted astrologers, farmers watched anxiously, and whole kingdoms paused to wonder what change the heavens were announcing. We now know these wandering visitors are simply ice and dust, tracing ancient orbits through the quiet dark. Ancient astronomers tracked seasonal change through shifting daylight length. Long before clocks, people noticed how the sun rose earlier in summer and lingered longer before sinking into evening. They watched shadows lengthen and shorten across the months, learning to predict harvests, floods, and migrations from these gentle rhythms. In this way, the sky itself became humanity's first and gentlest calendar, quietly marking the slow turning of the year. Let your shoulders soften now, sinking a little deeper into whatever is holding you. There is nowhere you need to be, nothing left to solve tonight. Let your breath slow, each exhale a little longer than the one before, like a tide gently receding from shore. Thoughts may drift by like distant clouds, and you can simply let them pass, unhurried, unheld, dissolving quietly into the dark. Isaac Newton described time as an absolute universal flow independent of events. He imagined it moving forward everywhere at the same steady rate, like an invisible river flowing evenly, whether anyone was there to watch or not. In his view, time simply existed, untouched by what happened within it, ticking onward silently beneath the motions of the stars, the tides, and every human life. It was a comforting, orderly picture of the universe. Gottfried Leibniz argued against Newton, proposing time is relational, defined by the order of events. Rather than a river flowing on its own, Leibniz imagined time as something arising only from change itself, from one moment relating to the next. Without events, without motion, he suggested, there would be no time to speak of at all. It was a quieter, more intimate view, tying time gently to the unfolding of the world. Galileo reportedly used his own pulse to time pendulum swings. Watching a lamp gently sway in a cathedral one evening, he noticed its rhythm never seemed to hurry or slow, no matter how wide the swing became. With nothing but the steady beat of his own heart, he measured these movements, uncovering a pattern that would later shape the science of timekeeping itself. A quiet observation, made from stillness, changed how the world understood motion. The pocket watch made personal timekeeping portable in the 17th century. For the first time, an individual could carry the hour quietly within a coat pocket, feeling its small, steady weight against their chest. These delicate brass instruments, often engraved and cherished, transformed time from something read on a distant tower into something held close, personal, and intimate. Time had, in a sense, become something one could carry home. Railroads forced the standardization of local time zones in the 19th century. Before trains, every town quietly kept its own local time, set gently by the sun overhead. But as rail lines stretched across countries, this patchwork became impossible to coordinate safely, and travelers grew confused by clocks that disagreed from station to station. Slowly, regions agreed to share unified time zones, letting trains and the people upon them move through the world in graceful harmony. The United States Standard Time Act of 1918 legally established time zones across the country. What railroads had practiced informally for decades finally became law, dividing the nation into orderly bands of shared time. It was a quiet piece of legislation, yet it wove together a vast landscape of farms, cities, and coastlines into a single rhythm. From that point on, distant strangers could agree, simply and gently, on what hour it was. The Greenwich Prime Meridian became the global time reference in 1884. Delegates from around the world gathered and agreed that this single line, passing through a quiet observatory in England, would mark the starting point for measuring time everywhere on Earth. From that line, every clock, every time zone, every scheduled sunrise and sunset could be gently calculated. A small hill in London became, quietly, the heartbeat from which the whole world learned to keep time together. Wristwatches became widely popular after the First World War. Soldiers in the trenches had discovered that fumbling for a pocket watch cost precious seconds. So many strapped their timepieces to their wrists instead, close and quick to read. When those soldiers returned home, they brought the habit with them, and what had once seemed a delicate accessory became an everyday necessity. Time, already personal, now rested gently against the pulse itself. Quartz clocks, developed in the 1920s, use vibrating crystals for precision. Inside each one, a tiny sliver of quartz hums at a steady, invisible frequency when touched by electricity, ticking with a regularity no pendulum could match. This quiet vibration, too fast and fine for human ears, became the new heartbeat of accurate timekeeping. Homes everywhere slowly filled with this unseen, crystalline pulse. Albert Einstein proposed that time is relative rather than absolute in 1905. Quietly working as a patent clerk in Switzerland, he imagined chasing a beam of light, and from that gentle daydream unfolded an entirely new understanding of the universe. Time, he realized, does not tick the same for everyone everywhere. It bends softly depending on motion and perspective. A single thought, patiently followed, reshaped how humanity understood its own passing hours. Let your shoulders soften now, sinking a little deeper into whatever is holding you. There is nothing left to figure out, nothing left to hold on to. Let your breath grow long and unhurried, like a slow tide easing back from the shore. With each exhale, imagine the day quietly dissolving, leaving only stillness behind. You are allowed to simply rest here, weightless, unhurried, safe. Special relativity shows that time slows for objects moving near the speed of light. The faster something travels through space, the slower its own clock ticks compared to one that stays still. This is not an illusion of measurement, but a real and gentle stretching of time itself. A traveler moving swiftly enough would age imperceptibly less than someone waiting quietly behind. The twin paradox describes a traveling twin aging slower than one who stays home. Imagine one sibling boarding a swift starship while the other remains gently rooted on Earth. When the traveler returns, still youthful, their twin has quietly grown older, having lived through more ticks of ordinary time. It is a strange, tender puzzle, showing how motion itself can gently reshape a lifetime. Time dilation has been confirmed using atomic clocks flown on airplanes. Scientists once placed extraordinarily precise clocks aboard commercial jets and compared them afterward to identical clocks left quietly on the ground. The airborne clocks, ever so slightly, ticked differently, exactly as Einstein's gentle equations had predicted. It was a quiet, careful experiment that turned an abstract idea into something you could hold in your hands and measure. Muons created in the atmosphere survive longer than expected due to time dilation. These tiny particles form high above us when cosmic rays strike the air, and by their ordinary lifespan, they should decay long before reaching the ground. Yet because they move at nearly the speed of light, time slows gently within their own brief existence, letting them survive just long enough to reach the Earth below. Even the smallest specks of matter carry this quiet cosmic secret. General relativity shows that gravity itself slows the passage of time. Near a massive object, like a planet or a star, time moves just a little more slowly than it does farther away in empty space. This means a clock resting near the ground ticks at a subtly different pace than one lifted higher above it. Gravity, in its own quiet way, gently stretches the fabric of time itself. Clocks at higher altitudes tick faster than clocks at sea level. A timepiece resting atop a quiet mountain experiences gravity ever so slightly weaker than one resting beside the ocean, allowing its ticking to move a touch more swiftly. The difference is impossibly small, mere fractions of a second across a lifetime, yet it is real and measurable. Even altitude gently shapes the pace at which time unfolds. DPE satellites must correct for relativistic time differences to remain accurate. High above the Earth, these small orbiting machines experience both weaker gravity and swift motion, each pulling their onboard clocks in gentle, opposite directions. Engineers quietly built these corrections into every satellite, so the maps and directions we rely on stay true. Each time a phone finds its way home, it is softly borrowing from Einstein's insight about the flexible nature of time. Time runs slightly slower at Earth's core than at its surface. Deep beneath our feet, where gravity gathers more densely around the planet's center, the passage of time eases back by the smallest of margins. Over the whole age of the Earth, this quiet difference adds up to just a couple of years. It is a strange and tender thought that the very heart of our world is, in its own way, a touch younger than the ground we walk upon. Near a black hole's event horizon, time appears to slow to a crawl for outside observers. As anything approaches this quiet boundary, its clock, watched from far away, seems to tick more and more slowly, stretching each second into what looks like an eternity. Light from the object grows dim and reddened, fading gently rather than vanishing all at once. From a safe distance, it is less like an ending than a slow, soft dissolve into stillness. An object falling into a black hole appears frozen in time from far away. To a distant observer, it never quite seems to cross the boundary, its image lingering at the edge, dimmer and dimmer, like a photograph slowly fading in sunlight. From its own perspective, however, the object continues quietly onward, feeling nothing unusual at all. Two gentle truths exist side by side, each one perfectly real from where it is seen. Let your shoulders soften now, sinking a little deeper into whatever is holding you. There is nothing to solve tonight, nothing to hold on to. Let each breath arrive on its own, slow and unhurried, and let it leave just as easily. Imagine your thoughts drifting like distant, dim starlight, present but far away, asking nothing of you. You are allowed simply to rest. Inside a black hole, space and time may effectively swap roles. Beyond the event horizon, the equations describing this place grow strange and dreamlike, suggesting that moving forward becomes as unavoidable as moving through space once was outside. Falling inward may no longer be a choice but simply the only direction left, the way we can only move forward through today. It is one of the gentlest, strangest ideas physics offers us. Black hole singularities mark a point where known physics breaks down. At the very center, according to our present equations, matter appears to compress into an infinitely small point, and our understanding simply runs out of words. Scientists believe this signals not a true ending, but a gap in our knowledge, a place where new ideas are still waiting quietly to be discovered. Even our finest theories, it seems, have their gentle limits. Wormholes are theoretical shortcuts connecting distant points in space and time. Picture two far-apart places folded gently together, like a sheet of paper bent so its ends softly touch, offering a hidden passage between them. No one has ever observed one, and scientists are unsure whether they could ever truly exist or remain open long enough to pass through. Still, the idea itself carries a quiet, hopeful kind of wonder about the shape of the universe. The Big Bang is considered the beginning of time as we understand it. In the earliest instance scientists can describe, all of space, matter, and energy emerged together, and with them, time itself began quietly ticking forward. Everything we have ever measured, every clock and every calendar, traces its rhythm back to this one distant origin. It is humbling to think that time, like us, had a soft and singular beginning. Before the Big Bang, the concept of time may not have existed. Scientists still don't fully understand what, if anything, came before. And it may be that the question itself does not quite make sense the way we imagine it. Without space or change, there may have been nothing for a clock to measure at all. It is one of those rare, wide mysteries that invites quiet wonder rather than any need for an answer. Planck time is the smallest meaningful unit of time, roughly 10 to the negative 43rd seconds. It is a duration so brief that our current physics cannot describe anything shorter, as though time itself becomes grainy at that tiny scale. Scientists believe below this threshold, the very idea of moments in sequence may lose its meaning. It is a soft reminder that even something as familiar as a passing second has a delicate, mysterious foundation. Cosmic inflation expanded space faster than light within fractions of a second. In that first fleeting instant, the universe is thought to have swelled enormously, stretching space itself far beyond what light could ever cross in that same sliver of time. This does not break any law, since it was space expanding, not anything moving through it. It is a gentle thought that the universe took its very first breath in less time than it takes to blink. The universe's expansion rate is measured by the Hubble constant, named for the astronomer who helped reveal that galaxies are drifting apart. This gentle number tells us how quickly distant space is stretching with every passing year. Scientists still refine its exact value, comparing measurements from starlight and from the universe's oldest glow. It is quietly remarkable that something so vast and slow can be captured in a single patient number. Entropy's steady increase gives time its forward-moving arrow. In simple terms, entropy is a measure of disorder, and in nearly every process we observe, it gently grows rather than shrinks. A cup of hot tea cools, ink spreads through water, and stars slowly burn their fuel away. This quiet drift toward disorder may be the very thing that lets us tell the past from the future at all. The past hypothesis proposes the universe began in an extremely low entropy state, setting time's direction. In its earliest moments, the cosmos is thought to have been remarkably ordered, almost like a perfectly folded cloth, before slowly unfolding into the wider disorder we see today. This one soft assumption helps explain why time seems to flow one way, from order toward gentle spreading disorder. It remains one of physics' quiet, foundational mysteries. For now, let your thoughts settle like still water. There is nothing to solve, nothing to hold on to, only the soft rise and fall of your breath. Let your shoulders soften into the bed beneath you. Let your jaw loosen. Let your hands rest open and unclenched. With each breath out, feel yourself sinking a little deeper into stillness, drifting gently toward sleep. Some physicists argue time's arrow is emergent rather than fundamental. In this gentle view, the flow we feel so certain about may not be woven into the deepest laws of nature at all, but instead arises from the particular way our universe happens to be arranged. At the most basic level, the equations often look the same whether time runs forward or backward. It is a quiet suggestion that the river of time may be more like a pattern than a rule. The heat death of the universe describes a distant future of maximum entropy. In this far-off vision, stars will have long since burned out, matter will have spread thin across immense darkness, and energy will have settled into a smooth, unchanging calm. It lies unimaginably far ahead, long after everything familiar has faded. Scientists describe it gently, not as an ending to fear, but as the natural, slow settling of a very old universe. In a state of heat death, no further change or events would occur. Without pockets of order left to unwind, nothing would move, react, or transform, and the universe would simply rest in perfect even stillness. There would be no stars to shine, and no motion to mark one moment from another. It is less an ending than an eternal, undisturbed quiet, the deepest stillness imaginable. Some cosmologists speculate the universe could reach a state where time effectively stops. If no change remains possible, there may be nothing left for time to measure, since time and change seem so deeply intertwined. Whether this counts as time ending or simply time losing all meaning remains a gentle open question. Either way, it invites a soft, wide kind of wonder about how something so familiar to us now might one day quietly dissolve. Loop quantum gravity suggests time may be quantized into discrete units. In this gentle theory, time might not flow in an unbroken stream, but instead advance in the tiniest possible steps, like grains falling in some impossibly fine hourglass. Each step would be far too small for us to ever notice, hidden beneath the smoothness of ordinary life. It is a quiet thought that beneath our seamless days, time might tick in secret, delicate increments. Physicist Julian Barber has proposed that time does not fundamentally exist. He suggests that what we call time may simply be our way of ordering different arrangements of the universe, one gentle configuration after another. There is no ticking clock woven into nature itself, only a vast collection of moments, each complete and whole. It is a soft, unusual idea that motion and change might be stories we tell about stillness. Barber's plutonium model treats each moment as a static, timeless configuration. In this vision, every possible arrangement of the universe exists on its own, complete and unmoving, like a single page rather than part of a flipping book. What feels like the passage of time to us may simply be our mind drifting from one page to another. Nothing truly moves between them. They simply are, each one resting quietly in its own eternal stillness. The block universe theory holds that past, present, and future all exist equally. In this wide, gentle view, yesterday and tomorrow are not gone or waiting, but simply exist alongside today, the way distant cities exist alongside our own, even when we cannot see them. Nothing about this moment is more real than any other. It is a peaceful way of imagining existence as one vast, unmoving whole, rather than a fleeting present balanced between loss and expectation. In the block universe view, time's flow may be an illusion of consciousness. The moving present we feel so certain of might be something our minds create, a soft spotlight sweeping gently across a landscape that itself never moves. Physics, in this telling, does not insist that now is special. It is simply where our awareness happens to rest, like a single warm point of light traveling quietly across a still and patient field. Quantum mechanics allows particles to exist in superposition until observed. Before a gentle act of measurement, a particle may rest in a soft blend of possibilities, not yet settled into any single outcome. It is neither here nor there, neither this nor that, existing instead in a hushed, undecided haze. Only when observed does it seem to settle, quietly choosing one path from among the many it had been softly holding all along. Let your body soften now, just a little more. There is nothing to solve, nothing to hold on to, nothing waiting for your attention. Let your breath slow, deep and unhurried, like a tide easing gently onto a distant shore. Let your thoughts loosen their grip, drifting apart like soft clouds, dissolving into open sky. You are safe, you are resting, and there is nowhere else you need to be. The quantum Zeno effect shows frequent observation can slow a system's evolution. When a quantum system is watched again and again, in rapid, gentle succession, its natural drift toward change seems to hesitate, almost as if caught mid-breath. Each glance resets its quiet progress, holding it closer to where it began. It is a strange and tender idea that simply looking, softly and often enough, might gently slow the unfolding of what is watched. Some interpretations suggest observation itself can freeze a quantum state. In this delicate reading, the universe may respond to attention the way still water responds to touch, settling wherever it is gently pressed. A watched particle, held in constant, soft awareness, may resist drifting into new possibilities. It is a quiet, wondering thought that awareness and reality might be linked more closely than we ever imagined, each shaping the other in silence. Time crystals are structures that repeat in time rather than only in space. Ordinary crystals repeat their pattern quietly across distance, like tiles in a floor. Time crystals, instead, repeat their pattern gently across moments, cycling in a steady rhythm without ever settling into stillness or losing energy. They move softly and endlessly in place. It is a delicate new kind of order, one written not into shape, but into the quiet unfolding of time itself. Time crystals were first created in a laboratory in 2016. Researchers cooled charged particles and arranged them into a delicate rhythm that repeated forever without settling. It was the first time such an odd, lovely order had been coaxed into being. Scientists who had once only imagined this pattern watched it appear quietly under careful, patient conditions. A theoretical whisper had become something real, glowing faintly in a controlled and silent chamber. Time crystals do not violate the laws of thermodynamics despite their name. They do not create energy from nothing, nor do they defy the quiet balance the universe keeps. Instead, they exist in a delicate, restful state, moving without truly changing, cycling without spending themselves. Scientists describe this as a kind of graceful equilibrium, order that persists gently, asking nothing extra from the world around it. It is motion held softly within stillness, disturbing nothing. Closed, time-like curves are theoretical paths that loop back to their own past. Imagined within the graceful mathematics of relativity, these curves suggest that under certain rare conditions, a path through space and time could curl gently around and return to where it began. Nothing walks such a path in our everyday world. Still, physicists find comfort in exploring these quiet possibilities on paper, tracing loops that fold time back upon itself like a slow, drifting ribbon. Kurt Gödel found solutions to Einstein's equations, allowing time travel loops. In 1949, while pondering the deep structure of the universe, he discovered that certain rotating configurations of space and time could theoretically permit a journey back to one's own past. He offered this not as prophecy, but as a quiet mathematical possibility, tucked gently within the vast landscape of general relativity. It remains a strange, beautiful curiosity, resting undisturbed in the equations. No confirmed physical mechanism currently allows travel backward through time. Despite these graceful equations, nature has shown us no doorway, no gentle passage that leads back into what has already happened. Scientists continue to hold the idea softly, curious but unhurried, aware that mathematics can dream further than matter has yet followed. For now, the past remains settled and still, resting quietly behind us, unreachable but never far from wonder. The grandfather paradox illustrates logical problems with time travel. It imagines someone journeying backward and preventing their own grandfather from ever meeting their grandmother, unraveling the very thread that led to their own existence. The puzzle folds gently upon itself, without offering an easy answer. Thinkers turn it over slowly, like a smooth stone in the hand, finding in it not fear, but a quiet, curious tangle worth sitting with. The Novikov self-consistency principle suggests time travel could not change the past. It proposes gently that if travel backward were ever possible, events would always arrange themselves so nothing contradictory could occur. The past would remain whole, undisturbed, no matter how far one reached into it. It is a soothing thought in its own way, a universe that quietly protects its own story, keeping every thread in its rightful place. Let your body soften now, just a little more. There is nothing to solve, nothing to hold on to, nothing waiting for your attention. Let your breath slow, deep and unhurried, like mist settling low over quiet water at dusk. Let your thoughts loosen their grip, drifting apart, like slow smoke rising into a still night sky. You are safe, you are resting, and there is nowhere else you need to be. Some physicists propose parallel universes to resolve time travel paradoxes. In this gentle idea, a traveler moving into the past might simply step sideways into another branch of reality, one where their choices unfold without disturbing the world they came from. Nothing breaks, nothing contradicts itself. Instead, the universe quietly multiplies, offering each possibility its own soft, separate space to exist within, undisturbed and complete. The many worlds interpretation suggests all quantum outcomes occur in separate universes. Each time a quantum possibility might have gone one way or another. This gentle theory imagines reality softly branching, allowing every outcome its own quiet existence elsewhere. Nothing is lost, nothing is chosen over another. The universe simply spreads outward, endlessly and calmly, holding every possible moment somewhere within its vast, unfolding embrace. Multiverse theories imagine other universes with entirely different time structures. In some of these gentle proposals, time might not flow forward at all in certain realms, or it might branch, loop, or move through dimensions we cannot picture. Scientists offer these ideas softly, as possibilities rather than certainties. Somewhere beyond our own sky, perhaps, time wears an entirely unfamiliar shape. Some cosmologists propose the universe cycles through endless big bangs and crunches. In this soothing vision, expansion and collapse repeat without end, each universe dissolving quietly into the next beginning. There is no final moment, only a long, breathing rhythm stretched across unimaginable stretches of time. It offers a strange comfort, the thought of existence rising and settling, again and again, like a tide with no shore. The theoretical Big Crunch describes the universe collapsing back into a singularity. In this quiet scenario, galaxies would drift closer together over unimaginable spans of time, gravity slowly overtaking the outward pull of expansion. Space itself would gather inward, folding gently toward a single point. It remains only one gentle possibility among several, a distant and speculative ending scientists still hold loosely. Astronauts orbiting Earth age microscopically slower than people on the ground. This happens because their speed and distance from Earth's gravity slightly alter how time flows for them, in keeping with the gentle laws Einstein described. The difference is impossibly small, a fraction of a second across months in orbit. Still, it means a small sliver of the future waits for them quietly when they return home. Cosmonaut Sergei Krikalev holds the record for relativistic time gained in space. Across many months spent orbiting Earth over several missions, his fast, quiet passage through orbit allowed him to slip a tiny fraction of a second into his own future. It is a gentle, almost invisible gift, mere fractions of a second, yet a real and measurable one, carried softly upon his long journeys above the world. Deep space travel near light speed could return astronauts to a far future Earth. If a ship could journey close enough to that great speed, time would pass far more slowly for its travelers than for those left behind. A voyage that felt like a few quiet years on board might correspond to centuries passing gently across the Earth they once knew, waiting patiently for their return. Some animals, like tardigrades, can suspend biological activity almost entirely. When conditions turn harsh, these tiny creatures curl inward and slow their inner processes to something close to stillness, waiting patiently for gentler days. They can rest this way for long stretches, untouched by time's usual demands, then softly return to motion when the world around them feels safe again. Hibernation slows an animal's biological perception and use of time. Through the cold months, a hibernating creature lowers its heartbeat and temperature, drifting into a long, unhurried stillness. Its sense of passing days grows faint, almost suspended, until warmth returns and slowly coaxes it back toward wakefulness. It is nature's own quiet lesson in patient, restorative rest. Let yourself settle a little deeper now, sinking softly into the quiet weight of the mattress beneath you. There is nothing to think through, nothing to carry forward. Let each breath grow longer, slower, like a tide easing gently back from the shore. Let your shoulders loosen, your hands rest open, your mind grow still and wide as a windless night sky. Cryonics research explores preserving bodies to effectively pause biological time. Through extreme cold, researchers hope to slow the body's processes almost to stillness, holding it gently suspended for some imagined future. Whether such a pause could ever truly be reversed remains uncertain, a question science still holds with quiet humility. Still, the dream itself is tender, a wish to meet tomorrow a little later than expected. The human brain constructs the sensation of now from delayed sensory information. Every sight and sound reaches you a fraction later than it truly happened, gathered and stitched together into something that feels immediate. What you call the present moment is really a quiet reconstruction, a gentle illusion assembled just behind the curtain of awareness. It is a small miracle that feels so effortlessly whole. Trauma can cause people to perceive time as slowing during dangerous events. In moments of sudden danger, the mind sharpens its attention and gathers far more detail than usual, which later makes the memory feel stretched and slow. Survivors often describe those seconds as endless, filled with vivid, almost frozen impressions. Scientists believe this is memory's density playing tricks on our sense of duration, not time itself changing at all. Positive emotional peaks, such as extreme joy, can make time feel like it passes faster. When we are delighted and fully absorbed, the mind stops counting moments and simply lets them flow together. Afterward, looking back, the hours seem to have slipped by gently, almost unnoticed. Joy, it seems, asks time to move quietly, so we may stay lost inside the feeling a little longer. Meditation and flow states can alter one's subjective sense of passing time. In deep stillness or complete absorption, the usual ticking awareness of minutes seems to fade into the background. Some describe a feeling of time widening, of moments becoming spacious and unhurried. Others feel it vanish altogether, replaced by a single, seamless sense of being fully present. Dreams can compress or expand experienced time compared to real elapsed minutes. A whole imagined lifetime might unfold within a few minutes of actual sleep, or a single dream moment might stretch on softly for what feels like hours. The sleeping mind seems unbound by the clock's steady rhythm, free to shape time however the dream requires. It is one of the gentlest mysteries the night still keeps for us. Children often perceive time passing more slowly than adults do. Each day for a young child is filled with new sights, new textures, new small discoveries, and novelty seems to stretch our sense of duration. A single summer can feel like its own small eternity when everything is being noticed for the first time. As familiarity grows with age, the days quietly begin to feel shorter. Aging brings biological changes that make time feel like it speeds up. As routines settle and fewer new experiences arrive, the mind has less novelty to anchor each day, and the years begin to blur softly together. Some researchers also link this shift to gradual changes in the body's internal clockwork itself. Whatever the cause, many older minds describe the passing years as gentler, quicker, softer at the edges. Boredom is associated with a subjective slowing of perceived time. When little is happening to hold our attention, the mind has few markers to measure the moments by, and each minute can feel unusually long. Waiting rooms, quiet afternoons, and empty stretches of stillness often seem to stretch further than the clock agrees. It is a strange comfort, in its own way, a reminder that attention itself shapes how time feels. The brain's internal timing relies on regions like the basal ganglia and cerebellum. These deep structures quietly help us judge short intervals, coordinate movement, and sense rhythm without any conscious effort. Scientists believe they act together like an inner metronome, keeping our actions and perceptions gently synchronized. It is humbling to think such quiet, hidden machinery shapes something as personal as our felt sense of time. Let yourself rest now in this soft, unhurried quiet. There is nowhere to be, nothing to solve, only this gentle moment holding you. Let your breath slow further, each exhale a little longer than the last, releasing whatever the day still held. Let your thoughts loosen their edges and drift like slow clouds, formless and unhurried, as your body sinks deeper into rest. Circadian rhythms are governed by the suprachiasmatic nucleus, a tiny cluster deep within the brain. It sits just above where the optic nerves cross, quietly reading light and darkness through the eyes. From this small region, signals ripple outward, telling the body when to wake, when to rest, when to release the hormones of sleep. It is remarkable that something the size of a grain of rice can conduct such a vast, invisible rhythm. Jet lag occurs when circadian rhythms fall out of sync with local time. The body's inner clock, tuned to one place, finds itself suddenly asked to live by another. Sunlight arrives at the wrong hour, meals come too early or too late, and sleep resists its usual invitation. Slowly, gently, over days, the inner rhythm realigns itself, like a compass needle settling after a long turn. Sensory deprivation experiments show people lose accurate track of elapsed time. In rooms without light, sound, or any marker of change, volunteers have guessed hours had passed when only minutes had. Without the world's gentle cues, the mind seems to lose its usual thread. Scientists believe our sense of time depends heavily on the small, steady changes around us, more than on any clock within. Some meditation traditions describe moments of timeless awareness during deep stillness. Practitioners speak of a quiet space where the usual sense of before and after softens, and only presence remains. These moments are not claimed as escapes from time, but as glimpses beneath its surface. Many describe returning from such stillness feeling unusually settled, as though something in them had been gently smoothed. High-speed cameras can capture events too fast for the human eye, like bullets in flight. What appears instant to us unfolds, on film, into a slow and graceful sequence. A droplet splitting, a wing beating, a spark leaping, all reveal hidden stages our eyes were never quick enough to see. It is a gentle reminder that our perception of time is only one possible window onto motion. Stroboscopic light was historically used to make moving objects appear frozen. By flashing light at precise intervals matched to a spinning or vibrating object, engineers could make wheels seem still or motion appear suspended mid-air. It was an early, elegant trick of perception, using darkness between flashes to fool the eye. Even now, it offers a soft lesson in how easily stillness can be an illusion of timing. Stop-motion animation creates the illusion of frozen moments between film frames. Each tiny figure is nudged, ever so slightly, then photographed again and again, until stillness becomes the illusion of graceful movement. Between every frame lies a small, silent pause, invisible to the viewer, yet essential to the magic. It is a patient, gentle craft, built from thousands of frozen instants strung softly together. The phrase "stop the clocks" is a common English idiom for grief or shock. It captures a feeling many have known, that in moments of deep loss, ordinary time seems to lose meaning entirely. The world outside continues, yet something within feels unwilling or unable to move forward just yet. The phrase gives quiet shape to a very human experience, the wish for time to pause when the heart is not ready. Miss Havisham's stopped clocks in Great Expectations symbolize frozen time. In Charles Dickens's novel, she halts every clock in her house at the moment her heart was broken, and lives on among them, unmoving in her wedding dress grown pale with dust. The image lingers gently in literature as a portrait of grief that refuses the forward pull of days. Her stillness reminds us how deeply sorrow can feel like time itself refusing to continue. In Sleeping Beauty, an entire castle falls into 100-year magical sleep. Not only the princess, but every soul within the walls drifts into stillness together, cooks mid-stir, guards mid-step, the whole household suspended in the same soft dream. Around them, the story tells us, thorns and roses grow slowly over the sleeping towers, nature continuing its quiet work while time within stands still. It remains one of the gentlest images of a world paused in tenderness. Let your shoulders soften now, sinking a little deeper into whatever holds you. There is nothing to solve here, nothing to remember. Let your breath grow long and unhurried, each exhale slower than the one before. Thoughts may drift by like slow clouds, and you need not follow any of them. Just resting here, unwinding, is enough. Let the mind loosen its grip, gently, gently, like a hand opening in sleep. Washington Irving's Rip Van Winkle sleeps for 20 years, missing time's passage. In the old tale, he wanders into the hills, rests beneath a tree, and wakes to a world quietly rearranged without him. His beard has grown long, his friends have aged or vanished, and the town he knew has gently become something new. It remains one of literature's softest visions of time, slipping past a sleeper, unnoticed and unhurried. The film Groundhog Day portrays a man endlessly repeating a single day. Each morning, the same song plays, the same snow falls, and the same small town awakens exactly as before. Slowly, gently, the repetition becomes less like a trap and more like a quiet invitation to notice what he had overlooked. The story lingers as a soft meditation on presence, suggesting that even a looping day can be lived with new tenderness. Doctor Who has frequently depicted alien technology capable of freezing time. Across the long-running series, strange devices and enigmatic beings have paused entire rooms, streets, even galaxies, mid-motion. Dust hangs suspended, clocks stop mid-tick, and characters wander through stillness like visitors in a painted world. These stories gently explore a very old longing, the wish to step outside time and simply look around. Marvel's Doctor Strange is depicted manipulating and looping time streams. Using a glowing amulet, he bends moments backward and forward, repeating a single sequence gently until the right outcome emerges. The imagery is dreamlike. Golden circles spinning in the air, time folding softly like fabric. Though wrapped in fantasy, the idea echoes a very human wish to revisit a moment and let it unfold with a little more care. George A. Louis Borges wrote extensively about circular and infinite time in his fiction. His quiet, labyrinthine stories imagine libraries without end, gardens where every path forks into another moment, and lives that repeat like verses in a long, unhurried poem. Borges seemed to find comfort rather than dread in these loops, suggesting that time might fold gently back on itself, again and again, like a book endlessly rereading its own pages. Kurt Vonnegut's Slaughterhouse 5 portrays a character unstuck in time. Billy Pilgrim drifts without warning between moments of his life, young and old, peaceful and difficult, never quite anchored to a single now. The novel treats this drifting gently, almost tenderly, suggesting that a life might be better understood all at once, like a long, quiet photograph, rather than a single unfolding line. The film In Time imagines a world where lifespans function as currency. In this soft, unsettling vision, Minutes and hours are traded like coins, and a glowing clock on every arm counts down what remains. Beneath its modern surface lies an old, familiar ache, the awareness that our hours are limited and precious. The story asks, gently, what we might value differently if time itself were something we could see ticking away. H.G. Wells' The Time Machine popularized time travel as a literary genre. Published in 1895, it carried its inventor forward through centuries in a single quiet journey, watching civilizations rise and fade like passing seasons. The novel opened a door in the imagination of an entire era, inviting readers to wonder, softly, what it might feel like to watch time move as a landscape rather than a moment. Ancient philosopher Zeno proposed paradoxes questioning motion and time. Living in Greece long ago, he wondered how anything could ever truly move if a journey could always be divided into smaller and smaller steps. His puzzles were never meant to trouble the mind for long, but rather to reveal how strange and layered our simplest experiences of time and motion truly are, hidden gently beneath their familiar surface. Zeno's arrow paradox questions how motion is possible if time is made of instants. He imagined an arrow in flight, frozen at every single moment of its journey, motionless in each. If every instant shows stillness, he wondered, how does the arrow ever travel at all? The puzzle lingers softly, reminding us that movement and stillness may be closer companions than they first appear. Let your shoulders soften now, sinking a little deeper into wherever you rest. There is nothing to solve tonight, nothing to hold on to. Let each breath arrive slowly and leave just as slowly, like a tide with nowhere urgent to be. Thoughts may drift by like distant clouds, and you need not follow any of them. Just resting. Just here. St. Augustine wrote extensively about the mystery of time's nature in his work called Confessions. He confessed with quiet honesty that when no one asked him what time was, he understood it perfectly. Yet the moment someone asked, the answer slipped away. His wondering was gentle rather than frustrated, a candlelit search into something so familiar it had become almost invisible. Augustine argued the present has no duration, existing only as a fleeting boundary. He pictured it as a thin, impossible edge between what has already gone and what has not yet arrived. The moment you try to hold it, it becomes the past. This delicate idea, though puzzling, invites a kind of tenderness toward each passing now, however brief it may be. Immanuel Kant proposed that time is a mental framework rather than external reality. He suggested that our minds arrange experience along time's gentle current, the way eyes arrange color and shape, not because the world demands it, but because that is simply how we are built to perceive. Time, in his view, might be less a river outside us and more a lens we quietly carry within. Henry Bergson distinguished between clock time and lived, experienced duration. He noticed that a ticking clock divides moments evenly, yet our inner sense of time stretches and contracts, rich with memory and feeling. A quiet afternoon can feel endless, while a joyful hour passes in a breath. Bergson called this deeper flow duration, time as we actually feel it, not merely measure it. Martin Heidegger explored being and temporality as deeply intertwined concepts. He believed that to exist at all is to be woven through time, always arriving from a past and reaching toward a future not yet lived. For him, understanding ourselves meant understanding our relationship with time itself, not as a backdrop, but as the very fabric our being moves through. Buddhist philosophy describes each moment as impermanent and constantly dissolving. Nothing, in this gentle teaching, stays fixed even for an instant, every sensation and thought arising only to pass away and be replaced. Rather than something to fear, this dissolving is offered as a quiet comfort, a reminder that clinging to any single moment was never truly possible to begin with. Taoist thought emphasizes flowing with time's rhythm rather than resisting it. Like water moving around stone, the wise person is encouraged to bend gently with the seasons of life instead of pushing against their natural course. There is a soft trust in this philosophy, a willingness to let moments unfold in their own time, without struggle or force. Stoic philosophers advised focusing only on the present moment as truly real. They taught that the past is gone and the future uncertain, so peace is found by resting attention gently in what is happening right now. This simple guidance, offered over 2,000 years ago, still echoes softly today, inviting us back, again and again, to this quiet, breathing moment. The concept of an eternal now appears across many mystical traditions worldwide. Mystics from vastly different cultures and centuries have described glimpses of a present so complete it seems to hold past and future within itself. In these accounts, time does not vanish but softens, becoming less a line and more a single, luminous point. Many traditions call this glimpse a kind of homecoming, a return to something that was always quietly here. Some indigenous cultures conceive of time as cyclical, rather than linear. Instead of a straight path from beginning to end, time is imagined as turning gently, like seasons returning or rivers curving back toward familiar shores. Ancestors, descendants, and the living present are often understood as woven together in this circling movement. There is a deep comfort in this view, a sense that nothing is ever fully lost, only returning in a new form. For a little while now, let the thoughts loosen their grip, like leaves, letting go of a branch. There is nowhere else you need to be, nothing left to solve tonight. Feel the weight of your body settle a little deeper into softness. Let your breath grow long and unhurried, each inhale arriving gently, each exhale releasing a little more stillness into the dark. The Aboriginal Australian concept of dream time blends past, present, and future. In this understanding, ancestral beings shaped the land and its laws in a time that is not simply behind us, but continues to exist alongside the present. Stories, songs, and landscapes are seen as living threads connecting what came before with what is happening now. Dreamtime suggests that time may be less a corridor and more a wide shared space. Ancient Egyptians envisioned eternity as both endless repetition and stillness. They held two ideas gently side by side, one of unending cycles like the sun's daily journey, and another of a deep, motionless permanence beyond change. Together, these ideas painted eternity not as a single straight forever, but as something layered, both flowing and utterly still at once, existing in calm harmony. The Ouroboros symbol represents time as an endless cycle without beginning or end. Pictured as a serpent gently swallowing its own tail, this ancient image appears across many cultures, quietly suggesting that endings and beginnings might simply be the same soft point, viewed from different sides. There is something soothing in its perfect, unbroken curve, a shape with no sharp edge, no place where anything truly stops. Hourglasses became popular in medieval Europe as portable timekeeping devices. Unlike sundials, they worked indoors, at sea, and through the night, their steady trickle of sand offering a quiet, visible rhythm to mark passing hours. Sailors, monks, and scholars alike watched their slow fall with patient attention. There was something almost soothing in their design, a reminder that time, like sand, moves gently and without effort. The phrase, "the sands of time," originates from hourglass imagery. Watching grains slip steadily from one glass chamber to another, people began to speak of moments slipping away in just the same soft, continuous manner. The phrase carried into poetry and everyday speech, gently reminding listeners that each hour passes as quietly and surely as sand settling at the bottom of its glass. Sundial mottos often included the Latin phrase tempus fugit, meaning time flies, carved into stone or bronze. These quiet inscriptions greeted anyone who paused to check the hour, offering a gentle, unhurried reminder rather than a warning. "Time flies," the sundials whispered, "so let each moment be noticed and held softly, rather than let slip by unseen." The metronome, invented in the early 1800s, standardized musical timing. Before its steady ticking arrived, musicians relied on instinct and memory to keep a shared pace. With its patient, even beat, the metronome offered a small, dependable pulse, allowing entire orchestras to breathe together in time. In its rhythmic simplicity, it echoed something ancient, the comfort of a steady heartbeat guiding many voices as one. Sustained musical notes, or silence, can create an illusion of suspended time. When a single tone lingers in the air, unchanging, the mind briefly loses its usual sense of forward motion. Silence, too, can stretch strangely, a held breath before the next sound arrives. In concert halls, listeners often report feeling as though the world outside has paused, wrapped gently in one long, unbroken moment of sound or stillness. John Cage's composition, titled 4 minutes and 33 seconds, consists entirely of silence, questioning musical time. Performers sit before their instruments without playing a single note, while the audience listens instead to the quiet shifting sounds of the room itself. Cage wished to show that silence is never truly empty. That time continues to breathe softly, even without music. His piece invited listeners to notice the passing moments they usually overlook. Fermata symbols in musical notation instruct performers to pause time briefly. Shaped like a small curved eyelid resting above a note, the fermata tells musicians to hold a sound, or a silence, longer than its written length. For a breath, the steady pulse of the piece gently suspends itself, hovering in place before continuing onward. It is a tiny, deliberate stillness written directly into the flow of music. Let yourself settle a little deeper now, into the quiet weight of the blanket, the softness beneath you. There is nothing to hold on to, nothing to solve. Let your breath slow, longer on the way out than the way in. Feel your shoulders loosen, your hands grow heavy and still. Thoughts may drift by like slow clouds, and you can simply let them pass, unhurried, unattached, as you rest. Long exposure photography can make moving water appear as a frozen, silky blur. By leaving the camera's shutter open for many seconds, every ripple and current blends into one smooth, glowing ribbon. Waterfalls become soft veils of light. Rivers turn into gentle streaks of silver. In this way, photographers borrow time itself as their medium, gathering many fleeting moments into a single, tranquil image. Contemporary art installations sometimes use frozen clock imagery to evoke stillness. Sculptors and artists suspend clock faces mid-motion, their hands bent or melted, inviting viewers to sit with the strange comfort of a moment held apart from ordinary time. In galleries lit softly, visitors often pause longest before these pieces, drawn into a quiet contemplation about what it might feel like for time to simply rest. Salvador Dali's painting, titled The Persistence of Memory, depicts melting clocks. Set against a barren, dreamlike shoreline, soft pocket watches drape over branches and stone like warm wax. Dali painted the scene slowly, almost meditatively, drawing from dreams and the strange elasticity of sleep. The image has since become one of art's quietest meditations on how firmly or loosely time actually holds its shape. Dali's melting clocks are often interpreted as time losing its rigid structure. Rather than measuring hours with mechanical precision, the soft, drooping timepieces suggest that time can bend, stretch, and soften, much like memory itself. Viewers have long found comfort in this idea that time need not always march forward in sharp, unforgiving lines, but might instead flow gently, taking whatever shape the moment calls for. The Yet Walk scare in 1999 raised fears. Computers might miscalculate time entirely. Many early computer systems stored years using only 2 digits, and as the century turned, some worried that clocks and calendars might reset incorrectly, confusing decades of stored information. Engineers worked quietly through the final months, testing and repairing systems. When midnight arrived, the world's machines and its clocks continued on gently, unaffected. Leap seconds are occasionally added to atomic time to match Earth's slowing rotation. Our planet's spin is not perfectly steady, and over years it drifts almost imperceptibly slower. To keep clocks aligned with the sun's gentle rhythm, scientists sometimes insert a single extra second into official time, a quiet pause barely noticed by anyone, yet carefully calculated to keep our measured hours in harmony with the turning Earth. Earth's rotation is very gradually slowing due to tidal friction from the Moon. As the Moon pulls softly on our oceans, the resulting drag acts like a whisper of resistance against the planet's spin. Each century, our days lengthen by only a tiny fraction of a second, far too small to notice in any single lifetime. Yet across hundreds of millions of years, this gentle tug has stretched our days from something much shorter into the 24 hours we now quietly rely on. The International Bureau of Weights and Measures oversees the addition of leap seconds. Nestled quietly near Paris, this small institution keeps watch over the world's most precise clocks. Scientists there compare atomic time against the Earth's slow, wandering spin, deciding gently when an extra second is needed. It is a soft, careful task, performed without fanfare, ensuring that our clocks and our planet continue to drift through time together, side by side. Some engineers argue leap seconds should be abolished due to software complications. Adding an unexpected second can quietly confuse computer systems that expect time to flow in perfectly even steps. Global networks, satellites, and financial systems must all pause briefly to absorb this small correction. Some engineers gently suggest it may be simpler to let clocks drift slightly from the sun, rather than risk even the smallest software stumble. The atomic second is currently defined by oscillations of a cesium-133 atom. Deep within a cesium atom, electrons shift between energy states at an extraordinarily steady rate. Scientists chose this rhythm, over 9 billion vibrations, to define the length of a single second with remarkable precision. It is a strange and beautiful thought that something so small and invisible quietly anchors the pace of the entire modern world. Let your shoulders soften now, and let your breath grow slow and unhurried. There is nothing left to hold on to, nothing to solve, nothing to remember. Just the gentle rise and fall of your chest, steady as a quiet tide. Let your thoughts loosen their edges, drifting like soft clouds with nowhere to be. Rest here in this warm, unhurried stillness, and let sleep settle over you like a familiar blanket. Optical lattice clocks are now more precise than traditional cesium atomic clocks. Using grids of laser light, scientists trap atoms and observe their oscillations with even greater steadiness. These clocks are so precise that they would lose or gain less than a second across many billions of years. In their quiet laboratories, researchers continue refining our sense of time, chasing ever finer slivers of accuracy. Future timekeeping may rely on nuclear clocks based on thorium-229 transitions. Rather than watching electrons shift within an atom, scientists hope to observe subtle changes deep within its nucleus. These nuclear transitions occur with such steadiness that they could one day surpass even today's most advanced clocks. It is a gentle reminder that our search for precision continues to move quietly inward, toward smaller and smaller worlds. Some physicists speculate quantum gravity could reveal time is not fundamental. In their quiet theoretical work, they wonder whether time, much like temperature or pressure, might emerge from something deeper and more elemental. If true, the ticking clocks we rely on may simply be reflections of an underlying reality where time, as we know it, does not truly exist at its core. Unifying quantum mechanics and general relativity may fully explain time's nature. These two great frameworks, one describing the smallest particles, the other the vast curve of spacetime, still speak in different languages. Physicists gently continue searching for a shared vocabulary between them. Should they succeed, our understanding of time itself may finally settle into something more complete, more whole. Scientists continue debating whether time's flow is an objective feature of reality. Some believe the passing of moments is woven into the universe itself, while others suspect it may arise only within conscious minds like ours. There is no rush to settle this question, and perhaps there need not be. The mystery remains soft and open, inviting quiet wonder rather than urgency, as we continue simply living moment by gentle moment. Some physicists argue that time is fundamental, a true thread woven into reality itself, not something built from smaller pieces. In their view, time cannot be reduced further, no matter how deeply we search. It simply is, they suggest, one of the basic ingredients of existence, alongside space and matter. This idea offers its own kind of comfort, as though time has always been quietly holding everything together. A philosophy called presentism holds that only the present moment truly exists. The past has slipped away, this view suggests, and the future has not yet arrived, leaving only this single sliver of now, glowing quietly. Everything you have ever felt has happened within one of these fleeting nows, appearing and dissolving like breath on a cold window. There is something tender in imagining reality as this ever-renewing instant. The philosophy called eternalism holds that all moments of time are equally real. In this gentle view, yesterday and tomorrow exist just as fully as this very instant, each resting together within one vast, unmoving whole. Nothing is lost, nothing is yet to come. Everything simply is, side by side, like pages bound within a single book. It is a quiet way of imagining that nothing we love ever truly disappears. Physicists have yet to find direct experimental evidence distinguishing these philosophies from one another. Presentism and eternalism both agree with everything our equations and instruments have shown us so far. No clock, no telescope, no careful measurement has settled which picture is true. And so, for now, the question rests gently unanswered, held with patience rather than urgency, as science continues its slow, careful watching. Ultimately, the felt experience of time standing still remains a deeply human mystery, one that outlives every myth and measurement we have gathered along this journey. From ancient suns that paused at the horizon to clocks ticking gently at the edge of black holes, we have wandered through wonder together tonight. Now, let that wondering settle in you like starlight sinking into still water. You need do nothing more than rest here, held gently in this present moment, exactly as it is. Sleep well, dear listener. Good night.